Now we may discuss the structure of all of the elements that make up the world as we know it in relation to the periodic system of the elements. Let us represent the various elements by showing how their electrons occupy orbitals, and we can plot energy vertically. We start out with the 1s orbital. Hydrogen can have one electron in the 1s orbital. I represent it by putting in an arrow pointing upward. Helium can have a second electron, 2 electrons in the 1s orbital. I show then the arrow pointing down. By Paul's principle, that is all the orbitals, the electrons that can be placed in the 1s orbital. The next orbital is 2s. When we come to lithium, the lithium atom with 3 electrons can have 2 in the 1s orbital, giving a completed helium shell, and then 1 in 2s. Beryllium, with atomic number 4 and 4 electrons, can be represented by having 2 electrons in the 2s orbital. Its electron configuration is 1s squared, 2s squared. Then we have the 3 2p orbitals. They can be occupied successively by electrons in boron, carbon, nitrogen, oxygen, fluorine, neon. At neon, this shell too is completed, the neon shell. Now we come to the third shell in the periodic table, a 3s orbital, 2 3p orbitals, and that's all that I want now, 2 3p orbitals. The succession of elements here, sodium, magnesium, scandium, silicon, phosphorus, sulfur, chlorine, argon. This succession of 8 elements brings us up to the noble gas argon, and we can say that this third shell is the argon shell. Next we come to the fourth shell. With atomic number 19, potassium, here we have 2 electrons, 10 electrons, 18 electrons. These numbers 2, 10, and 18 are characteristic of the first 3 noble gases. With potassium, we have the 4s electron. With calcium, then, a pair of 4s electrons. Then the 4p orbitals and the 4d orbitals. 1, 2, 3, 4, 5 of the 3d orbitals. This shell is called the krypton shell, a shell of 18 electrons occupying 9 orbitals. Along here, whereas here in the shorter shells we have only 4. These can be occupied by 18 elements: potassium, calcium, scandium. I think that I said scandium down here. Of course, here I should have said sodium, magnesium, aluminum, silicon, and so on. Here we have the first long period of 18 elements: potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton. This ends up with krypton, and we call it the krypton shell of 18 elements.